On behalf of the GAABESU Research Awards 2024-25, I welcome all of you to the second part of the presentation sessions today. To all the presenters, you have up to 10 minutes to present your slides. That will be followed by a 2 to 3 minute question answer session. Our first presenter today is Dr. Indrajit Dey from Metallurgy and Material Science. Thank you.
Shall I start, sir?
Yes, please.
Good evening, everyone. Myself, Dr. Indrajit Dey. Today, I'm going to discuss about my PhD topic, that effect of microalloying on microstructure and properties of high carbon steel. And I have pursued my PhD under the supervision of Professor Swarup Kumar Ghosh and Dr. Rajiv Saha. So basically, the microstructure mechanical properties in carbon steels is a subject for considerable research for the researchers. Now, microalloying coupled with thermomechanical control processing replaces the conventional carbon manganese silicon steels or expensive heat-treated alloy grades for their good strength toughness combinations at low temperature as well as for cost effectiveness. It is well known that carbon content increases the strength, but at the expense of fracture toughness. And other things are that the microalloying additions can also be done. Some microalloying elements are vanadium, niobium like this, and these are the carbide carbonitride formers in conjunction with the solution treatment temperature and finish rolling temperatures of TMCP, that is thermomechanically controlled processing. So quenching partitioning is another thing, a novel process that we have used in our steel, which is basically comprising of austenitization at a requisite temperature above AC3, that is the austenite finish temperature, and subsequent quenching to a temperature between martensite start and martensite finish, followed by holding for a certain period of time to allow the carbon partitioning from supersaturated martensite to the carbon depleted austenite in order to facilitate the austenite stabilization at room temperature, partially or fully. There are plenty of research are available on this aspect for low and medium carbon steels. However, very few studies have been carried out till date on this aspect for high carbon steels, especially when it is niobium microalloyed steels. So it is well now the effect of various alloying elements that are present in our composition, in our steel composition. It is well known that if the carbon increases the strength, but if the carbon content increases 0.8 weight%, then embrittlement may occur due to the formation of continuous grain boundary cementite network, which is undesirable. However, the combined addition of silicon and niobium is beneficial for a palladic steel without forming this cementite network. And manganese is a austenite stabilizer. It also increases the hardenability. It also reduces the deleterious effects of sulfur by forming the MNS. Silicon acts as a graphitizer. Niobium contributes to the grain refinement either by precipitation pinning or by grain boundaries by solute drag effect. So these are the some of the applications where our steels can be used. And at the bottom, let me show the pointer. So at the bottom, I have shown a very critical application, that is a tire cord. So these are made of high carbon steels, and other applications also include that suspension bridge cables, T-rails, etc. So our objective in this part is to understand the effect of prior austenite grain size on pearlite formation and morphological parameters such as nodule size, colony size, pearlite interlamellar spacing. For two high carbon steels we have selected. One is with niobium, another is without niobium. And also we have done a modeling approach where we have done some microstructure based modeling by using finite element method. And we have to estimate the elastic and elastoplastic properties of the steel. So without doing any experiment. And also we have evaluated the effect of various mesh size and RV sizes on these models. To design another third objective was to design a novel niobium microalloyed steel that have excellent mechanical properties by optimizing two key parameters. One is increasing the content of manganese silicon while keeping the carbon concentration as same as the two other steels, HC0, HC1. And this one is designated as HC9, the latter one. And second was the quenching partitioning time and temperature variation in order to stabilize the volume retained austenite and then calculate the volume percentage of retained austenite and then at room temperature. So this is the first part. At the top, I have given the chemical composition, the chemistry of the two steels. As we can see, all the other elemental compositions are same, except niobium. Niobium is a microalloying element in case of Hc1, and Hc0, it is not present. So at the in the bottom, I have shown prior austenite grain size variation with respect to austenitizing temperature. And for this, we have done some, we have selected some few samples, and then we have done some after austenitizing, we have done the quenching to room temperature, water quenching, to evaluate the prior austenite grain size, and I have plotted this results in this curve, in this graph. So at the bottom, I have shown some microstructures, optical microstructures, which is basically for these optical microstructures we have obtained by using this thermomechanical control processing route. So these are basically showing us that white boundaries are the ferrites, and at the in the interior, the perlite column is perlite. So the darker phase are perlite. So to investigate in details, we have also done some TEM studies as well as some AFM studies. So TEM studies clearly reveals that the addition of niobium significantly reduces the perlite interlamellar spacing. So these are the interlamellar spacings. We can see this is the without niobium sample. This is the with niobium samples. In the bottom, I have shown some fine niobium carbide precipitates, which we have witnessed from this TEM study. And in order to confirm these precipitates are niobium carbide, we have done some EDS analysis, and this EDS analysis confirming this is the niobium carbide precipitate. So these are the various values, various morphological parameters which we have calculated by using this 10 to 40 micrographs, and then we have evaluated this. We have calculated these various morphological parameters, and in order to determine the how much the variation of interlamellar spacing, or is there any calculation error or something like that, we have also done some AFM studies, and the result is shown here that the TEM studies and AFM studies match well. In the bottom, I have shown that how the perlite interlamellar spacing, that is inverse square root of perlite interlamellar spacing, how the refinement of interlamellar spacing increases the hardness and strength of the material of the steel. So this is our first part. The second part is dealing with the microstructure based modeling approach that I have mentioned earlier. So we have selected some high resolution FEACM image, and we have divided into several parts, as I have shown in the left hand side top corner figure. We have also done the mesh size and RV size valuation. So this is the RV size valuations. So these are the elastic and plastic properties of the two phases present, ferrite and cementite. The white phases are cementite peaks, and the valleys are the ferrite. So these values I have taken from the literatures, and then we have done some elastic analysis by using UF2 software, that is object-oriented finite element method, and another is the Abacus software for evaluating the elastoplastic properties. These are the boundary conditions we have given, and these are the results that we have obtained, and we have used this Ludwig equation for these calculations in the plastic region. So we can see that in the plastic equivalent strain distribution, as it is expected that in the ferrite matrix, it is the high. It is high, and for cementite, it is less. In the reverse is happening here in the von Mises stress distribution. So these are the various curves, true stress strain curves that we have obtained from using this post-processing and then the model generated results. These are basically, so this is the experimental data, the solid line, the solid green line, that experimental stress strain curve, and we can see that our modeling results also validates well with the experimental data. So this is the X direction we have done, and this is the Y direction. So these are the various strain hardening coefficient we have also plotted by equation using these equations. And these are the other parameters that we have used. At the bottom, I have shown some fracture surface morphologies. So there I have shown the coalescence of voids, dimples, presence of dimples, cleavage facets, etc. So this is the third part where we have chosen a slight different chemistry by increasing the manganese content and silicon content in order to stabilize some amount of written austenite and to create the trip effect, that is the transformation induced plasticity effect for our steel and high carbon steel. And so this is the dilatation curves we have obtained at different cooling rates. We have used Glibel in this case. So this is the continuous cooling transformation diagram that I have generated by using these data. And these are the various transformation temperatures that are I have shown for various cooling rates. So at various cooling rates, we can see the transformation temperatures is lowering, and it is an indication that the refinement of the final product with the increase of cooling rate. So these are the other, so in order to compare this, we have also done some empirical equations calculations and also thermocalc gematro analysis, and these are the values of various temperatures for this steel composition. So this is the this is another part of the same study that we have done some quenching partitioning. So in the A and B, that is the hot rolled air cooled samples where the FRT was 1000 degrees Celsius, and C and D is basically the quenching partitioning samples that quenching partitioning was done 200 degrees Celsius. I have shown that MS was Martin's start temperature was 215. Around 215. So we have varied the temperatures, and these are the results that some benite, martensite, and some other phases are also present, but I'll show it later. In the 180 degrees Celsius, quenching partitioning 180 degrees Celsius samples, I have shown some optical and SEM micrographs where various phase constituents like pearlite, ferrite, benite, martensite, written austenite can be seen here. And these are the same results, and this is the 160 degrees Celsius samples. So these are the TM studies that we have done. So this is basically.
I would request you to fast forward your presentation because we are close to time limit. Thank you.
Sure. These are the TM studies. So these are confirming the phases that we have witnessed in optical and SEM studies. So these are basically showing those. And this is the fine niobium carbide precipitates, the corresponding ACED pattern. So to confirm, confirming this niobium carbide, and these are the solubility products, the niobium carbide solubility products that we have calculated by using the bottom equations as shown below. So these are the other results, which is X-ray analysis that is showing, and the bottom I have given in tabular form the volume percentage of written austenite, how much we are getting. So we can see that highest volume percentage of written austenite we have obtained for quenching partitioning 200 degrees Celsius samples. So it is 10, and carbon content in written austenite we have calculated by using this formula. And these are the various other phase constituents by using empirical equations. And these are the mechanical properties. So we can see we are achieving 2000 MPa, almost 2000 MPa strength for this steel, which is a novel process. So the conclusions are rise of austenitizing temperature. With the rise of austenitizing temperature, pearlite volume fraction increases, ferrite volume fraction decreases, AGS austenite grain size, NS also increases with increasing AT. And volume fractions of PF and unresolved ferrite and unresolved pearlite are more in case of HC1 than HC0. Other important conclusions are that the niobium addition results in the refinement of the interlamellar spacing, and thereby AFM results also substantiate lambda measured from the TM study. The model generated results also stood well with the experimental results, and we can see that we can use this model without doing any experiment. So this model is capable to predict the elastic and elastoplastic properties of a two-phase microstructure. These are the other conclusions, that increasing cooling rate decreases the transformation temperatures, indicating the finer products. And then other conclusions also include, as I have already mentioned, that highest written austenite 10% we have obtained for QP 200 degrees Celsius samples. And as it is very obvious that hardness values increases significantly with increasing cooling rates. So these are, however, the best combination of strength and ductility witnessed for QP 200 degrees Celsius samples. This is the percentage, and followed by QP 180 samples. So whatever I have learned here during my PhD, I have presently I'm associated with Jindal Steel and Power in the research development department, and I'm in the product development group. So these are the learnings I have applied in my industries that optimization of low quench hardness, high UTS, and microstructure in homogeneity issues in fastener grades like 10B35, 10B21 grades wire rods. I have done. Dejections of formation of grain boundary cementite network we have also reduced by significantly by modifying the process parameters and cooling regimes. Standard operating procedure was made through a series of experiments to set the correct austenizing temperature and time. Construction of CCT curve, etc., and mean flow stress calculation. Another thing I have also done here is to evaluate the TNR, no recrystallization temperature, and all those things. Regular characterization under optical and SEM microscope I am doing here. So these are the list of publications that I have done during my PhD, and whatever I have shown here, the 9 number, it is the last part, quenching partitioning, that has been published in Metallurgical Materials Transaction A in 2024. The modeling results I have published in Steel Research International, and the first one that I have shown that I have published in 2018 in Materials Characterization Journal. And these are the other publications from my PhD work. Thank you.
Thank you very much, Dr. Dey, for your detailed presentation. I'm now inviting questions from the awards committee.
Recording in progress.
Hey Indrajit, my name is Biman, by the way. I'm 81 Metallurgy, and I see Professor Partha Chatterjee is also in the call. So I don't know, during your tenure with the PhD studies, Partha has a lot of experience in this area, and I'm thrilled or excited to see that the work we started back in the 80s in the department with different kinds of partitioning of manganese and microalloy constituents and all that, you are advancing that work. So I see the smiling face of Partha, and probably, like, I don't know, like in terms of your publication, etc., you have collaborated with Partha or not. But just to add to that plug-in that Professor Chatterjee has loads of experience in this Benedict transformation, the amount of characterization that you did, different types of structural characterization especially, and the modeling. So I really, really, like, from the bottom of my heart, congratulate you in advancing those studies. Just one quick note, since you are adopting those kind of modeling approaches, and I see that you went up to like 0.66% of carbon, what happens for your model if you go to like an eutectoid steel? And does your model suggest that, hey, if any kind of spherulitization of the perlite takes place, where the interlamellar spacing and their influence on different aspects, especially like I see that you have established the correlation with the von Mises criteria, the fraction perlite, benite, martensite, etc. It would be very interesting to know that what happens if you increase the carbon percentage further, just for a food for thought for future. But once again, congratulations, and I'm glad to see that you encompassed every aspects of this study. Thank you.
Thank you very much, sir. I'll study it in detail, but I want to tell here one thing that we have done this modeling only based on the microstructure-based modeling approach. This is also two-phase microstructure. Our model is validated, but we have a plan to further study. As you have mentioned, that is a new path for me also. So I love to study that. Thank you, sir.
Great job.
Do you have any more questions? Okay. Thank you for your presentation again, Dr. Dey. I think we can.
I think Partha was saying something.
Oh, Partha. Okay, sorry, Partha.
Hey,
am I audible?
Yes.
You are now. Yeah. Thank you.
Yes, sir.
Yeah. So I'm really glad to see that, as Bimanda has mentioned, that this tradition of steel research is continuing with very good quality of work. I have a couple of questions. How did you made the measurement of austenite grain size? You have shown in one of your plot, how does it vary? So how could you have austenite grain in the microstructure?
Sir, for that, we have selected different austenitizing temperature. We have selected few samples, and then we have done the austenitizing treatment followed by the water quenching at room temperature. So there is a martensite in the interior.
As you quench, austenite is not retained. austenite transforms into some other phase, maybe ferrite, pearlite, or whatever is your microstructure. But from a ferrite pearlite microstructure, how would you identify austenite grain size?
No, sir, that austenite grain size I have not identified from a pearlite microstructure. I have identified it from a water quench
How
sample.
did you get austenite grain?
Sir, interior was
Measurement
martensite.
of grain
So,
size, you need austenite grain. How did you get that?
yes, sir. After water quenching in our steel, the interior was filled with martensite, and surrounding the martensite there was prior austenite grain boundaries. So I have selected few prior austenite grain boundaries.
When you quench, as such, by normal etching, prior austenite grain boundary is not revealed.
So, sir, I have done the etching with 2% nitrile, and then I have seen
Maybe you have
this.
used some special agent or some technique. Check on that. And you have shown two different composition of steel. It is really interesting to see that particularly low carbon steel, where in one of which you have added niobium and the other was niobium free. So how could you maintain the composition of carbon and manganese similar in two different steel up to second place of decimal?
Sir,
It is really
this steel
interesting because I mean, we usually melt small volume of steel, and for that to maintain composition of carbon manganese in two different ingot uh, similar in up to second place of decimal, that itself is a, I mean, marvelous achievement.
Sir, this steel I have obtained from Tata Steel. So Tata Steel Jamshedpur. This was
You
a
analyze that?
collaborative
Did you
project with.
analyze it? Did you
No,
analyze
sir, I
it?
have not done any spectro or something like that. So I have done.
That is a quite I mean, lapse, because you should know what you are working with. And I have never seen that in two different steel, carbon and manganese appears similar in two up to second place of decimal in two different steel. It is really surprising. And how, what role does niobium play in refining the interlamellar distance of pearlite? What is the mechanism? You said that use of niobium refines pearlite grain size. What's the mechanism?
Sir, if there are interlamellar spacing is refining, so means there is small interlamellar spacing. So when we are giving
did you make it sure that it has triggered some precipitation at interlamellar boundary? That is between boundary of ferrite and cementite. There must be something at the interface which hinders the growth of ferrite and cementite lamellae. Usually niobium refines the prior austenite grain. But how come niobium is available during pearlitic transformation to refine pearlite microstructure?
sir, it
That
actually
needs
lowers the
clarification.
transformation temperature. It actually lowers.
Transformation temperature effect is something, but you have said that it is niobium which is responsible for that.
Sir, we have done some literature studies, and they are also claiming that.
See, in literature, I mean, first thing, blindly relying on literature is not, I mean, wise. Second thing, you are using different steel. Perhaps the steel which they have used is different. That is one thing. And you have done a lot of modeling, I can see. But how did you determine the temperature for quench partition treatment? Because when you are fixing the parameter, you need to know why are you going to treat the steel at 150 or 180 or 200 for quench partitioning. How do you know that at all the partitioning is happening? It can be different reason. Yes, you have come across certain variation in property, but it can be for different reason. How do you make sure that it is due to quench and partition?
Sir, carbon percentage in retained austenite and retained austenite volume percentage Sir, the image temperature was 215. So the idea was,
Partitioning is a kinetics, isn't
yes,
it?
sir. Yes, sir.
So, what makes you confident that carbon diffuses from austenite to martensite? Partitioning
Sir,
happening. There must
yes,
be
sir.
some thermodynamic reasons for that.
So Partha, sorry, we have to
Okay,
move on.
yeah, I mean, it is very
Oh.
interesting topic, and he has done a lot of work. So naturally, I thought certain clarification may be required. Okay, thank you, Indrajit. It is a good amount of work, huge volume. You have done a lot of characterizations. Okay.
Indrajit, can you clarify your position? You said you already doctorate. So we'd like to make sure that, your situation we can consider for this award, because we need to know, because this is for some students. So can you tell me when you graduated and what research you are presenting for this award?
Sir, this is my PhD topic that I have presented, and I have defended my PhD thesis on 16th of January on 2025. This 16th of January.
So you haven't graduated yet, right? You
Yes,
haven't.
sir. Sir, I have done a
Defended
PhD in
means
2020.
they offered provisional certificate to the candidate.
Okay.
Yes,
So,
sir.
okay. So, okay, you defended, but okay. So you are still, okay, you defended means, okay. So this year. But you will get your degree in next convocation.
Exactly.
Yes, sir. Yes.
Okay. Okay. All right. Thank you. Back to you, Ashirbani.
Thank you, everyone. Our next candidate is Mayukhi Pal. Mayukhi, can you pull up your presentation? Mayukhi is from Information Technology.
Sure, ma'am.
Hi.
Is my presentation visible, ma'am?
It's visible. Thank you.
Okay. Good evening, everyone. I would like to thank GAABESU for giving me the opportunity to present my work. So today I would like to present about the topic mosaic integration of single cell multiomic data using a variational autoencoder architecture. So first I would like to discuss the background and some of the key concepts. So in my project, I have focused on integrating transcriptomic and proteomic data. And this data is may have a certain noise due to batch effects, which can arise from different sequencing techniques or different library preparation techniques. And also there could be some problems due to limited cell numbers and sparse data. So that's why to have a joint analysis of multimodal data, we need to apply some techniques for integration, which I have done in my project. And for modeling my RNA data, I have used zero inflated negative binomial distribution because my data was sparse. And for protein, I used Poisson distribution. And I also implemented cross training and clip loss. Clip loss is basically contrastive loss, and it accounts for the cosine similarity of it basically maximizes the cosine similarity of um, similar data, and it minimizes the similarity of dissimilar data. So there are two objectives of my project. First is to project the data onto a common feature space to get a latent representation. And the second objective is to remove the batch effects, which is the noise that is incurred during procuring the data or processing the data. This is my model architecture, where the red array shows the RNA data and the blue array shows the protein data. The first encoder takes the entire RNA data as input, and my input is a count matrix where the cells are the rows and the features are the genes. And in case of protein, my features are protein markers. And from a correspondence matrix, we narrowed down the data just to the common features. And that common data is fed to the model in the middle, which is Q2. So now I would like to discuss briefly about the variational autoencoder. So the variational autoencoder assumes that there is a latent variable Z from which we get the actual data, which is represented by X, and the parameters of this distribution is given by theta. So we could write it as P of theta or Z given X. And by using the Bayes theorem, we can write it in the following manner. By Monte Carlo simulation, we have seen that this denominator is intractable, thus making this posterior also intractable. That's why instead of P of theta, we use an approximate distribution called Q phi of Z given X. And this is basically the decoder part. And since we do not have access to Z, we need to get it from X initially, and that is done by the encoder. And encoder is represented by P theta of, I'm sorry, just a second.
Is there any
So the
reason
encoder parameters. Hello.
why didn't you go for the presentation rather than making some calculations, etc. on the screen?
Okay, sir. So our objective is to maximize the likelihood of observing the data X, and that is given by the first formula here. The first term is the expectation for maximizing the likelihood between the encoder network and the decoder network parameters. And the next term is the KL divergence between P of theta and Q of phi. And since I have used the ZINV distribution for modeling my RNA data, I have shown the equation here. And for protein data, I have used the Poisson distribution, which is given below. And for my analysis, I have used a data set of blood cells, and it contains 228 protein markers, and the RNA, there were 10,000 features for RNA, which we narrowed down to 2,000 highly variable genes. And then we used a correspondence matrix to find the common features for corresponding cells. And the shared data was fed to the encoder shown by Q2, And I had two decoders for the shared joint model. One was for RNA and another one was for protein. And the loss function, as I had shown there, is the likelihood minus the KL divergence. And I have also implemented clip loss to maximize the similarity between the latent space representation generated by the unshared encoder and the shared encoder for RNA and protein respectively. And I have also implemented cross training where I have just interchanged the positions of the latent spaces and fed them through the different decoders as shown here, so that the knowledge transfer is good and the model can generalize well about the parameters of the distribution. And these are my results, where this plot shows batch mixing of the protein and RNA data. And the plots above, they show the clustering based on RNA and protein markers. Thank you.
Thanks, Mayukhi, for your nice presentation. I'm inviting questions. Okay, Kalpana Sharkar Majumdar has a question. Please go ahead.
Yes, thank you, Mayukhi. That's a wonderful data, and I'm very keen to those biodata, I would say. What's the application of your research? Where do you see that this will be applied in our human life?
Okay, ma'am. So the idea is to observe different domains of omics at the same time, at the same latent space representation, so that we can infer characteristics about the intrinsic features of different single cell organisms. And and by this we can also find a correlation between different omic domains like transcriptomics, proteomics, and genomics, and this will further help in downstream analysis.
Everything what you said, it's all in the terminology of your research, and somebody has a deep knowledge about all those RNA terminologies. But if I don't know anything, I'm a computer engineer. So to make sense to me, can you please take this another level up, in my language? Can you say that research, how is going to help me? Please.
Okay, ma'am. So we can only observe the characteristics of different organisms that we observe around us, but these are actually affected by some underlying patterns of say RNA or protein. So what we are doing here is we are observing the RNA and protein data, and we are seeing whether there is some correlation between them and how it is affecting the observed characteristics.
Good. Thank you. Congratulations.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
I'm a bit curious about Mayukhi, because this is a research presentation, so it's not under your course curriculum. Did you do this work under your supervision and you have presented somewhere?
Sir,
I mean, what are the
actually,
other
I
authors
am
out there?
still doing.
What the other contributors?
Sir, this was a part of my internship at IIT Kanpur, and I haven't published it yet because I am doing some hyperparameter tuning. My results for RNA are good, but the protein results need to be improved a bit. because the clustering needs to be more distinct. So yes, it's still under progress.
Okay, thank you.
Thanks, Sudipta. Mayukhi, I have one question for you. There are standard batch effect correcting techniques. I'm sure you must have heard about them, the combat technique. Have you tried comparing your methodology, at least the step one of your methodology, to that technique? Thank you.
No, ma'am, but I'll look into it. Thanks for sharing.
Okay, thank you very much.
Thank you, ma'am.
So we have our next presenter, and the next presenter is Sayak Bal from the Metallurgy and Material Science Department. Sayak, are you here? Hello, Sayak.
I don't see Sayak Bal. You can go to the next one.
Okay. So the next presenter is Soumyadeep Dey from Mechanical Engineering. Hi, Soumyadeep.
Good evening, ma'am.
Yeah. Would you please try to share your screen and
Yes.
presentation? Thank you.
Ma'am, is it visible?
It is visible. Thank you. It's not in presentation mode though. Yes, now it is. Thank you.
Oh, okay. Is it fine now?
It works. Thank you.
Thank you. Good evening, everyone. I am Soumyadeep Dey, a final year undergraduate in the Department of Mechanical Engineering at IIEST Shibpur. Today, I will present my research work that is enhancing in-plane elastic properties of sinusoidal oriented honeycomb by adding different oriented ribs under the supervision of Dr. Atul Jain in the Department of Mechanical Engineering at IIT Kharagpur. Sorry. Okay. So what is auxetic material? Auxetic material is the structure having negative Poisson's ratio. So when it is stretched longitudinally, it will also get expanded laterally instead of getting contracted, as you can see in the figure. And such structures have some superior mechanical properties such as high energy absorption, enhanced indentation resistance, and high shear stiffness. And these novel structures have some potential applications in automobile industry, aerospace industry, and biomedical field, mostly in the implants. What is reentrant structures? The term reentrant is used to describe something directed inwards or having negative angle, and this structure is quite popular in the study of auxetic structure. Okay. So as you can see, this is the conventional hexagonal reentrant honeycomb structure, and this is the sinusoidal reentrant honeycomb structure. In our study, we have used sinusoidal reentrant honeycomb structure to avoid high stress concentration at the inward joints. Now, if we increase the auxeticity of this structure, the stiffness decreases. But in several potential applications in biomedical implants, military sector, and automobile industries, the enhanced stiffness of this structure is really required. So our objective in the study is to enhance in-plane elastic properties of differently modified structures by adding differently oriented ribs to the base auxetic structure. So in our case, the base auxetic structure is this sinusoidal reentrant honeycomb, where T is the cell wall thickness. Then we have modified sinusoidal reentrant honeycomb with added reinforcements like SRH with horizontal rib, vertical rib, plus ribs, and we have the scaled down SRH inside SRH. Then we have SRH with double inclined rib, single inclined rib, circular rib, and elliptical rib. We have performed finite element analysis of these structures or models using abacus, wherein the loading we have applied periodic boundary condition, and we have also provided the displacement to each direction, that is direction 1 and direction 2 individually, and that is the 1% of total length at that direction. And in measuring, we have selected element type as CPSA, that is plane stress 8 noded quadrilateral element, and element size as 0.01. Our study can be divided into two subcategories. Where in the first, we kept the cell wall thickness and rib thickness constant, and we varied it from 0.6 to 1.2 for each orientation. And then in the second, we kept our cell wall thickness as 0.8, which is constant for each cases, and then we varied the rib thickness from 0.2 to 1.2 for each orientations. These are the some plots where it is the variation of specific Young modulus with cell wall thickness. This property increases with increase in cell wall thickness in both direction 1 and direction 2. Now here it is also the variation of specific Young modulus with rib thickness, change in rib thickness. Here the property increases with increasing in rib thickness like previously, same as in direction 1 and direction 2. Now here we have the variation of Poisson's ratio with cell wall thickness. Here the magnitude of Poisson's ratio decreases, so the auxeticity also decreases with increasing cell wall thickness, as you can see in both direction 1 and direction 2. And now here we have the variation of Poisson's ratio with rib thickness. The results are very similar, and the trend is very similar. The property, the auxeticity decreases, and the value for Poisson's ratio that increases with increase in rib thickness. Now to validate our numerical results, we have performed some experiments. As you can see from the bar chart, the overall trend is very similar for both cases in numerical analysis and the experimental analysis. The value of the property, that is specific stiffness or specific Young modulus, is nearly identical in both cases. And the major reason behind the error or the difference between the results is mostly due to the manufacturing defects, as the samples are 3D printed in FDM 3D printer. This is in the direction 1, and this is very similar in case of direction 2 as well. These are some experimental images. As you can see, the initiation and propagation of the deformations in the images. The cracks initiates from the points or the joints where the stress concentration is very high, and it propagates further. In conclusion, the specific stiffness increases with increasing in cell wall thickness and rib thickness. The value of Poisson's ratio mostly increases with increasing cell wall thickness and rib thickness. So the auxeticity, that is the negative Poisson's ratio, that decreases with increase in cell wall thickness. So here you can see the Poisson's, the auxeticity is inversely proportional to the specific stiffness. The specific stiffness is increased maximum by 1025.85% along direction 1 by adding plus rib orientation, and by 16,586% along direction 2 by adding vertical rib orientation. Auxeticity is decreased maximum by magnitude of 100% along direction 1, and by 98.37% along direction 2 by adding circular rib orientation. These are some references I have used for this presentation. Thank you for your kind attention, and thank you, GAABESU, for giving me this opportunity to share my research work. Thank you.
Thanks, Soumyadeep, for the nice presentation. I'm inviting questions now.
Ma'am, may I stop the sharing or should I continue?
You must.
You can keep the conclusion slide. Okay.
Okay, sir. Is it
visible? Yeah, visible. Okay, fine. As you understand that we are not expert of all fields, but we are just curious to know something from you. Okay. So just out of that curiosity, I'm asking you that one issue. I have found out that you have made a comparison with the so-called experiment and the theoretical analysis, isn't it? You have done something in the previously
numerical and experimental analysis, sir. Yes.
You did the experimental analysis and tried to validate with the theoretical results, is it?
Numerical results, sir. Yes, sir.
Numerical analysis. So my question is, that the accuracy, expected accuracy, you must have an idea. That means to what extent can you expect that particular accuracy between these two? You have assigned the manufacturing defects. I mean, there will always be a difference. If it perfectly matches, then obviously there is some confusion regarding the theoretical result and the experimental results. But do you have any idea how much accuracy you can at best expect from this sort of experiments? Because in all experiments, you don't get the similar accuracy.
Yes, sir. Sir, in our case, the error is maximum in one case only, that is 20%, but in mostly it is less than 10%. The error. I mean, these
So
are
it
the
is
values.
so it is satisfactory for you, huh?
I think yes, sir. 10% is, I think, considerable.
Okay. And going to the final conclusion conclusion slide, I just
Yes.
want to know here the increase is rather not very always common, 1,025 and 16,586%.
Yes, sir.
So I think you have rechecked it, no? It's okay because it may be my
Yes, sir.
limitations, the knowledge in this particular field. That's why generally in systems we don't find. That means with this spatial arrangement, you are gaining this much of advantage in particular one property, is it?
Yes, sir. Yes, sir. It has an reason. I mean, the vertical rib orientation in direction 2. So the rib is along the stress. I mean, the force, the external force. So that is why the stiffness can be increased this much.
Yeah, and substantially. Okay, I have
Yes, sir.
all the things clarified.
Thank you.
Can I comment on this particular issue, the percentage of increase? Is it due to the very small numerical value? When you do the percentage, sometimes it looks very high in terms of percentage. What is the absolute change
So
or
exact value.
difference? Means you calculate the percentage, correct? Based
Yes,
on two values. What are
yes,
the values there? That may be the very small value. When you divide it by a small value, the percentage may look very high.
Yes, sir. I mean, the first one is we compared the value of, I mean, after adding the vertical rib or the ribs and the base auxiliary structures without any ribs.
No, I understand that. How did you
Yes, and
calculate the percentage? Then what
yes,
is
sir. I mean,
the actual values?
Sir,
Yeah.
in the base auxiliary structure without any ribs, the value was really small. Yes, that can be a reason, yes, sir. For this
Means,
much high value.
in terms of millimeter, micron, can you give me a number?
So I have to check for it. I mean,
Sorry, it is a stiffness. Yeah, that's why what Sudip is mentioning.
So it
Dr.
is in the
that may be
decimal
the
position. I
reason.
could recall.
Yeah. That's why it is sometimes misleading to present this way with a very high percentage. Okay, that is the point. Okay, it's fine. Okay, thank you.
Thank you, sir, for the feedback.
Thank you. Do we have any more questions?
It is not question. Again, it is a curiosity. When you are using a honeycomb structure, basically purpose is to make it a lighter structure. I mean, without compromising stiffness.
Yes, sir.
So when you are adding reef, you are increasing number of joints, number one, and increasing the mass of the material. So does it compromise with the objective of design of honeycomb structure, or alternatively, you can change the design of honeycomb itself for enhancement of stiffness?
Sir, our motive is that to enhance the stiffness without much compromising in the auxiliary. Our prime and the auxiliary structures are in our case the
number of joints, which makes the structure susceptible to damage and failure, as you have seen in your experiment.
Yes, sir.
So that is a compromise.
Yes, sir. Okay. Sir, could you please repeat once? I mean, I couldn't get that. Sir. Am I audible, sir?
Yeah, Parthada?
You are audible. You are audible. You are audible.
Okay.
Sir, could you please repeat it once? I could not get that, sir.
My point is, when you are adding reef, you are adding additional mass to the structure. That is compromising the basic purpose of designing honeycomb structure. And second thing, you are adding more joint in the structure, and joints are always susceptible to failure, as it is evident from your experiment also and your model also. So is there a compromise in design? Or you could redesign the honeycomb geometry itself to achieve better stiffness.
Sir, to I mean, to restrict the part that is the deformation, like the higher stress concentration in the joints, we have used the sinusoidal rib instead of conventional honeycomb re-entrance structures. And so our motive is to increase the stiffness for stiff for the applications where the stiff mechanical properties are required or desirable. But these auxetic structures, while increasing the stiffness, the basic property which is the auxetic property, it is compromised a bit, but these all structures are auxetic in nature, with maybe lesser value from the base structure. And our motive is to apply these kind of structures in the biomedical implants mostly, or in the automobile sector or the military applications, where in this figure we can see these are this is kind of hip implants, or this is bone screw, these are used in the biomedical implants, and or maybe in military applications we need some stiffer honeycomb structures, dentin structures with having auxeticity property. So in those cases we need some more stiff structures. So our motive is like that.
Thank you, Shamuri.
Thank you, Sudhir. Thank you so much.
Thanks, Parthuda and Shomodeep. I think we can move to the next presenter. Our next presenter is Harsha Agarwal, and Harsha is from the Civil Engineering Department.
Hello, ma'am. Hello, everyone. Myself, Harsha Agarwal. I'm presently 4th year UG student in the Department of Civil Engineering, IIEST Shibpur. I would like to share my presentation. So hello everyone. As I introduced myself, Harsha Agarwal. Today I would be presenting my research paper, which basically the research work which I did in my third year, which I did in my summer internship, like the third year mandatory summer internship at Western University, Canada, under the supervision of Professor Ayan Pal. So my project topic is basically related to structural health monitoring, and in a deeper view, my project topic is leveraging deep learning for robust leak detection in water distribution systems using accelerations data. So the prime focus on of this project was how we can use accelerometers for leak detection, as well as how we can integrate deep learning for a better result. So moving ahead, like as stated here, for the objectives of the project, the first objective was to detect and classify leaks in water distribution networks, which can mitigate the water loss as well as it can maintain structural integrity. Second, of course, as mentioned, we can integrate a better cost-effective solutions where instead of leveraging on different type of sensors, which is very costly and expensive, we can instead we can use accelerometers, which is rather cheap and cost-effective, and we can get a better results out of it. And it is very sensitive to vibrations. Third, a robust CNN model is developed for accurate results. And CNN model was used because in some of the research literature survey which I have done, there were many research papers which has focused on different kind of models, but they have implemented a very vast pre-processing of data. But in the research work, there is no pre-processing of the data. The raw data which we got from the data set that has been integrated, and CNN is used because it provides that facility as well as very low computational time. So now focusing on next slide, it is the data set. So the basic data set which I have used, it is a benchmark data set which was published by Agassi in 2023. It is an experimental data set in which our experimental bed setup was done and all the data sets were recorded for different sensors. So as you can see from this figure, the data set consisted of two topologies, which is looped and branched, 5 different type of leaks, which is orifice leak, longitudinal leak, circumferential leak, gasket leak, and no leak. And again, for each of the leak types, we have different background conditions or the background flow which is simulated, like 0.18, 0.47, and no leak conditions. Then we have transient background conditions in which the flow is changing abruptly or suddenly. And for each of the case, we have different kind of sensor set, which is accelerometer, hydrophones, and dynamic pressure sensors. But in my research, I have used the all the topologies and leak type focusing on each of the background conditions. But for sensors, only accelerometer switches A1 and A2 is studied. So going on to next slide, my research method. The research method, as mentioned, I had used 1D CNN. So 1D CNN was used because it has very low computational time, as well as it does not require any pre-processing. We can manage by different parameters we are using in the code. So this was done in MATLAB, and the research method, which I mean, how to curate that CNN model. It was divided into two phases. One is model training, and the second one is model validation. And as you can see from the flowchart on the right, model training is divided into three steps. Like first was parameter optimization and evaluation. Second is performance metrics evaluation. Third is combination ranking and selection. I would describe each of them in details. So going to the next slide. This is a part of training process. The first part of the first phase, that is optimization. So as I mentioned, the CNN model which was developed, it was developed in a very generalized way. So in a CNN model, we had different set of parameters which can be optimized, like different combinations could be tried to get the best model, like a robust model which could adapt to all the different background conditions. So like in the flowchart, starting from window size, then convolutional networks, alpha value, epoch configurations, learning rate optimization, and L2 regularization. Various kind of different combinations from the ranges which is mentioned in each of the boxes was tried to get the best fit model out of it. And then as a second phase, like of the training process, which is evaluation. Throughout the evaluation, as I mentioned in my previous slide, for each of the parameter optimizations and all the different combinations that were tried, for each case, like we obtained the confusion matrices, which was for training purpose and testing purposes. So for each of the case, using the values which we obtained from the confusion matrix, a MATLAB code was used to get the different performance in matrices, that is accuracy, precision, F1 score, and recall. So for each combinations, all these 4 performance criteria were noted down, like what is the average value we are getting for each of the combinations. And as a part of ranking and selection, like it was categorized into different segments according to the parameters we are optimizing. And then the best fit parameter was chosen as a final model. So likewise, we developed 2 models, like one was for the looped topology and one was for branch topology. For the training purpose, 70% of the dataset was used and validation 30% of the dataset. And only one model was developed for each of the case and which focused only on data related to 0.18 liter per second. So moving on, like these are the validation results. Like I have shown only results of the training graphs. I mean, not the training, but I have shown results of only one background conditions. So this is the validation result which I got when the all the parameters were hyperparameter tuning was done. So first one is the training progress graph. Second figure is the training process confusion matrices, and third one is the testing process confusion matrices. So like this is the one which I got for 0.18 liter per second, and like it has performed very well. And this model was used to test for each of the other cases. So this is also the results which I got for the branch topology, same with a background flow of 0.18 liter per second. So like this model, like one for the loop and one for the branch with background flow of 0.18 liter per second was trained, was actually hyperparameter tuned according to the data, window slicing and everything. And when this model was performing like had an accuracy around 99% or greater than that, then we use this model for each of the other, like mentioned in my previous slides, like we have 5 different kinds of leaks and we have 5 different kinds of background flow, which is 0.18, 0.47, no leak conditions, which is 0, and transient background conditions. So only the model which was trained for 0.18 LPS was tested for all the other background conditions to check whether it is performing accurately or not. So as a part of result, like it is summarized in a table. Like as you can see from the table, this is the results of the training and the second is of the testing. So for the looped and branch, the 0.18 liter per second, they had an accuracy around 99.9 and 100% because they were actually trained absolutely as the data set it was there for the 0.18. And the same model was used for all the other flow conditions and all of them had an accuracy greater than 99%. So it was satisfying the criteria of the purpose of the research, because this data which we got from the benchmark data set is directly fed into the CNN. There is no pre-processing done and the computational time is very, very less. So I would like to conclude my presentation with the following notes. Like I developed a 1D CNN model using window slicing technique, and I used 1D CNN because most of the literature surveys have used 1D CNN, which was giving an accuracy very high, but a complex pre-processing process was involved. To avoid that, the main focus was to use 1D CNN and especially like how to integrate 1D CNN with accelerometer dataset because it is cheap. Secondly, demonstrated superior performance in both looped and branch water distribution networks. This shows like we can use this model for a diverse set of background conditions. And as a part of structural health monitoring, when it is performing, like a robust model is performing for different kind of background conditions, then instead of going for replacement, we can go for repairing of the pipes and maintain the structural integrity of the heritage buildings or the buildings which requires which can be solved in a less expensive manner. So going ahead, like, the model achieved high real time. It was highly accurate and a scalable leak detection was possible because of the feature extraction based ML model, that is 1D CNN, and the real time detection, like the training process and the detection time was as low as 0.0075 to 0.0125 seconds with a very high accuracy, and all the precision, all the performance matrices were at par with the accuracy. Lastly, there were very minimal variation in accuracy despite a very high changes in water flow conditions. Thank you. If there is any questions, I would like to answer that.
Thanks very much, Harsha, for your nice presentation. Now I'm inviting.
Thank you,
Good evening, Harsha. That is nice presentation.
Good evening, sir. Thank you, sir.
Good evening. What do you mean by scalable, and how do you go about that? Scalable for you in your conclusion. How would you scale it up? And what would you need for scaling up?
So in this scalable leak detection is like we actually have 5 we have 2 topologies, and for each of the topologies we have 5 different kind of leaks. So by mentioning scalable, I actually mean like for different kind of different conditions, we got a leak detection which had a very high accuracy.
Right. Okay. For both those, right? You had two.
Yes, sir. Yes, sir. For both the looped and branch, the accuracy was above 99% without any pre-processing.
Okay. All right. Okay, good. Thank you.
Thank you, sir.
Thanks, Dr. Bishesha. I have one question, Harsha. Did you mention the sample size of the training set anywhere in your presentation?
Ma'am, I have not mentioned actually.
It's there, right? I probably have missed.
Sampling. Should I share my presentation?
Yeah, just one second. I think.
Yeah, sure.
Here.
These are the results. Like I actually didn't get what are you asking?
So I'm saying, did you write anywhere the sample size of the training set?
Ma'am, it is not mentioned. Like it was a huge data set. Like
Yeah,
it
that's
had
why I
around.
want to know. Yeah.
Yeah.
Could you give me a ballpark estimate?
Like for each of the cases, I guess we had around maybe 30 or 40,000 of data points, and it was divided into 70% of training and 30% of testing and validation.
Okay. Okay. Thank you.
Harsha, you have mentioned about there is no pre-processing required for this particular work. So,
Yes, sir.
So this was the basically a data set provided to you from some available data, is it?
So this was it was an experimental benchmark data set which was published in 2023 by Agasai. Like he actually performed a diverse range by setting up the experimental bed. Like he did all the sensors, then he mentioned the pump, valve, then meter blocks, and for each of the point he actually measured how it is changing, like according to time, according to flow.
The problem arises when you go for any experimental or real life data. There are the possibilities of some outliers. Do you have any idea about the outliers?
Yes, sir. Before using this data, a sort of data analysis was done in which like we found out how the data, like for the different thing, what is the change in data? Like, is there any outliers, or maybe like the kurtosis value was found? So like a trend analysis was done beforehand, then only the graph was used because the amount of outliers were very less. And like in the CNN code, in fact, like there was some part, I mean, I actually can't explain to a great depth because this outlier was there for that I'm sure, because the PhD scholar helped me with this. Like he actually worked with the outliers, how we can get rid of them, because there were very few outliers in the data set.
Okay. And finally, do you have any idea about overtraining? No.
Yes, sir. So actually for the loop, like as you can see from the results chart, like for the branched one, like if you see the 0.18 liter per second, like it is performing 100% accurate. And even as shown before in the optimization, like we have gone one by one to different parameters. So like on branch case, like when we were training up to fourth or fifth parameter, it had already achieved the accuracy of 100%. And on changing any other parameters, it was showing 100%. But in case of looped topology, for it is 99.9, because in that L2 regularization, there was a particular value. If I use that value, accuracy was 100%. But when I use that same model for other flow conditions of looped values, then the results was like around 80% or maybe close to 90%. So I had to reduce the performance a bit for the training model so that it performs equally for the other models too.
Thank you.
Thank you, sir.
Thank you. Do we have any more questions? Okay. I think we can move to the next presenter now. Thanks, Harsha.
Thank you, everyone.
Our next presenter is Tamonash Bhattacharyya from the Information Technology Department. Hi, Tamonash.
Hello. Good evening, everyone. Am I audible?
Good, thanks.
Am I audible? Hello.
Yes, you are.
Oh, okay. Great. I'm sharing my screen. I hope my presentation is visible.
Your screen is visible? Yeah.
Okay.
Yeah, we see the presentation mode. Thank you.
Okay, okay. Shall I start now?
Yes, please start.
Yeah. Thank you. So, good evening, everyone. I'm Tamonash Bhattacharyya from the Department of Information Technology. Today, I'll summarize for you the work that I've done during my undergraduate under the supervision of Dr. Prashant Gosal and during my internship at the Advanced Multi-Course Core Laboratory at IIIT Delhi. So it's a culmination of all those works and a bunch of publications from that. And it's the broader topic would be AGI for healthcare. So, first, I'll give you the motivation that actually led us to this work and that helped us make decisions along the way for the work that has to be done. So the first one is the aging population and an increase in it and the increase in general population. And as a result of that, the decreasing number of quality medical resources that are there for dispatch. By resources, I mean medical centers and human resources from the same. And the potentially vulnerable target groups such as pregnant women and neurodegenerative and disease sector, and also in general aging patients that are most vulnerable to these things. So for all of this, we have targeted the development of assistive healthcare technology, which is basically a passive all-around wearable health monitoring system that parameterizes various biosignal information from surrogate endpoints and not clinicals, and thereby estimating health states at a very low cost and in real time on the flow, thereby keeping track without requiring human supervision. That has basically been the motivation of our work. So I'll move now to the research methodology that we followed along the way. The first one would be analyzing the state of the art of the system and then identifying the lacunas and identifying the research gaps and capitalizing over them to build our own system. Then we're identifying use case from the overgeneralized population, and then we focus on how we can solve that, and then we can move on from there into using the template to solve everything else. And the next step would be optimization, that is reconciling the edge hardware for the software implementation that we have done for the system, and in the final scope, developing the ASICs, that is basically a design of the hardware accelerator prototyping on FPGA for the edge applications. So the first use case that we have focused on primarily in undergrads is the adversarial fault detection. In common literature, the fault detection systems schemes are divided into three basic types, which is ambient-based, vision-based, and variable-based systems. I think the names are quite self-explanatory on what each of them entail. And but in our work, in the very first phase, what we did was study the state of the art to identify the research gaps. And from these gaps, we have seen three potential themes that each system should have in order to be commercially and economically and at the same time viable for the real-time deployment, which is basically having compact estimation models, which is memory efficient and compute efficient systems, and then being able to transfer between various environmental settings and still being accurate to a certain degree of accuracy. And finally, system architecture should be reliable with a very low EER rate. So a basic fault detection system entails two different types of sensors. That is the IMU, or the inertial measurement unit, and physiological sensors, sometimes which capture heart rate variability or skin conductance. And for our case, in our very final work, we have performed some sort of ambient sensing, because as I'll tell you in the later slides, that we have observed that the amount of day hours spent outside than a particular setting, and if you can switch between them, that can significantly reduce the model load. So this is the representation of the inertial signals I was speaking about. Each of the columns represents an axis, and each of the rows represent a particular activity. So thereby, I'll show you why the need of a deep learning architecture for solving such a problem. Anyone can argue that we can have a simple fast Fourier transform to analyze the particular trends, and then we can go about defining classifiers from that. But at the very heart of the system lies the fact that we need a very low specificity for a real-time system to be viable at deployment, so that they do not produce false alarms and false alerts and result in needless dispatch of medical resources. So as you can see, in each of these things, there is this, for a fault system, which is the last one, you can see there is this perturbations in spatiotemporal region. And from there, we can see that analyzing this perturbation is crucial to the detection of a false scope. But one might argue that there are similar kinds in all of the scales of what makes it different. Where classical methods depend on SVMs, or which is basically some vector magnitudes, you can always see that for static methods like that, an SVM will always fail in a real-time setting, since it's stream data and not just a comparable batch of windows. So what we have done in our setting is divided stream into segmented windows and classified them based on our classifiers. So the first solution is the dynamic environment solution, which we have designed based on keeping in mind the fact that the user can switch between various environments from time to time. And with this objective, we have defined a feature extraction backbone, which is basically a custom CNN. It's not a resonance extension or something architecture. With predefined type, we have created our own in-house custom CNN architecture, and have got an accuracy of 97.9% from that in real-time deployment settings. And what it does basically is that performs independent lecture analysis of spatiotemporal features, and then performs a dependent analysis of all the different axes to give a joint outcome. So why it's necessary is that because in a false setting, looking at one single axis will not give a complete picture of what the health state is. So one needs to compare the trends along various axes, along various sensors, and then combine them together in such a way that we can produce meaningful results. While doing the inertial axis might be enough, but for certain edge cases, for example, for a person who is lying down or is at a tilt angle of 120 degrees plus, which we have observed during our trial settings, is that it still leaves some use cases where this model also fails. So in that case, we have integrated a physiological signal, basically using a PPG to define HRVs. And what you observed during the time window during which that peak occurs during each of the acceleration, although it represents that of a fall, it is not always, since the PPG will never spike. But if a person actually falls, the heart rate variability also flickers during that time frame. So thereby we have a better classification algorithm than just use of IMUs. From this, so until this point, we had our work done on a fixed model approach, in which we use the model all throughout the architecture. But now we move on to a much more memory and communication channel efficient solution, which is basically using a model switching algorithm. So the motivation for this was the fact that a person spends very less amount of time outdoors, which is actually the requirement for a very heavy, very rather complex detection algorithm. So what you have is the ambient detection module, which is aided by ambient audio processor and a GPS module, and both of them are replaceable depending on the amount of granularity one is expecting. So the ambient audio processor performs FFTs, very basic FFTs on sound signals, and estimation for a bunch of classes where the person might be. So depending on that, we have the interrupt system that determines which algorithms to process. So if it's an indoor-based system, the variation on each of the inertial scopes is much less. So we can get away with using just a simple logic gradient regressor. So what that will get basically the same amount of specificity and sensitivity when compared to a more advanced, more complex architectures. But when a person moves to the outer environment, as when detected by a ping-based ambient audio processor, we move on to attention-gated CNN classifier. So the reason for using a bit more complex architecture that is basically attention gated at top of the CNN layer was because of mitigation of noise, rather than doing that on stream during signal propagation. We do it we keep it invariant in general, that's the idea. We keep it invariant and let the algorithm decide for itself. So what the attention mask does is that focus on the important segments. It's not a multi-rate, it's not multi-gated. It's just single rate for each for each actual information. So what it does is that like it performs like a mask around the most significant regions during its training step and uses that information during the testing. And so that's how like the complexity like gets shifted from when one wants to move from one environment to the other. And finally, for each of the steps that I've discussed for the visual component of it and the wafer component of it, we implement everything on a RISC-V based SSD FPGA. Basically, we have used the microchip polarized SSD, which is the world's first RISC-V FPGA. So the reason we are using RISC-V is that we wanted to bring the cost down as possible, and since RISC-V is open source, and so there are no proprietary licenses involved, which is contrary to what something you would have done on a Cortex system, which is owned by Xilinx, and there are a bunch of proprietary licenses built out of them. So, and besides that, there are technical reasons because like since RISC-V code, at least the architectures that we have used for prototyping, like produce 50% consume 50% less energy, and RISC-V in general is best extensible. So you can have a IIEST that is particularly catering to your application and have the ASIC very small memory and doing the same amount of computation than any other contemporary course. And using the use of an FPGA at a prototyping stage basically gives us the like freedom to apply high levels of parallelization. Since it's a lot of repetitive tasks for each of the accesses for each of the inertial signals, so our choice is kind of justified for this.
You need to.
Oh yeah, sorry, I'm so sorry. Okay, so in conclusion, I've like summarized the works, and we have, it's not that we have tested in the laboratory settings. We have actually tested with real-time data, and we have found the accuracy, sensitivity, and specificity of the code across all this, and all state of the art and the benchmarks, and we outperform each one of them. And like in conclusion, like we have other works as well in smart agricultural systems, which I don't think we have time to discuss. So. And these are the publications that we've got out of it. And the first four are from the political systems, and as a result of the work that we've done. The last one is from the smart agriculture system. So thank you. And I apologize for the any time constraint.
Thanks, Tamonash, for a nice presentation. I'm inviting questions. Devalda has raised his hand. He has a question. Yes, Devalda.
It's not a question, but just a suggestion, Tamonash. You're punching in a lot of technical details in a short period of time. That is understandable. But you want the audience to hear out what you're saying. Try to slow down a little bit. That will make a lot more sense. And you will be able to engage the audience better. This is just an advice. I mean, you can take it, you can, it's up to you. But, you know, talking a lot of technical details in a short period of time is not very easy. I do understand that. But if you need your audience to engage to what you're saying, and to be able to do that, you need to slow down and try practicing it. This is just a piece of advice. Thank you.
Thank you so much. I'll definitely try doing that.
It is a wonderful presentation, and we enjoyed. I have just another, not question actually. What is your future direction? Because the performance of other models, I can see that pretty good, but this is the something you can take outdoor, indoor. It is not confined to a room. Is it something can be used in a product, or launching a new product or anything like that?
Yes, actually, we're currently working on getting a patent and actually developing an ASIC with the help of I'm currently working as a PhD at the IIEST Center for Microelectronics Research. So like I'm looking at this as a side project to actually being implemented and getting a chip out of it, final design product ASIC. So that is a final outcome of our work. Then we can actually have an entire device and a product that we can actually sell and market. So that has been the plan from very first. Yes.
Is the IP protected?
No, not in the legal sense, no. It's still in my
that
computer. The code is still in the computer. Yes.
be careful. Even if you present, then you can lose the IP. That's why work with your advisor or senior who is guiding you.
Yes.
Be a little bit careful if you want to have some IP rights or have some product.
Thank you very much. I'll do
Okay.
that.
Yeah.
Thank you very much.
Tamonash, I have a question. Could you go to the slide where you were explaining the different components of your hardware?
Hardware, like fine. Okay.
Yeah,
So
this one.
this is the okay. This is not the hardware. This is basically the model architecture. That's the outline.
Okay. So here you're using the ambient audio processor to
Yes.
decide if the person is located indoors or outdoors. Did I hear you correctly?
Yes. Exactly. Yes.
Okay. So would you think in the long run that is going to suffice? Because the person might choose to work in some quiet environment, right? Maybe in a park.
Yes.
And then how do you
Yes.
think this could work? Or do you need to put some extra sensors?
Okay, so the cross-validation, like if you have an ambient audio processor, which is a low granular approach, you have the GPS module alongside it. So it's swappable, I understand. But if you have a GPS module, then you can, to a certain degree of extent, it can accurately say, okay, you are in a park setting. So it might happen that a steamroller might go past you and your sensor detects that and shows a peak, right? So like that might result in some misclassification. So, but then there is the ambient audio processor, which knows exactly that, that has happened. So there is cross-validation step. So if I have a GPS module, then even if I'm in a quiet park, I know I'm in an outdoor setting. I'm not in the home setting. So the cross-validation is.
Okay.
Yeah.
Thank you.
Yeah.
Do we have any more questions? Okay. Thanks, Tamonash.
Thank you so much.
Our next presenter is Rajesh Mondal. And Rajesh Mondal is from the Civil Engineering Department.
Yes,
Hi,
ma'am.
Rajesh.
Hello, ma'am.
Hello, and welcome. Would you please try to share your screen?
Yes, ma'am.
Yeah, we see your presenters, ma'am. Thank you.
1 minute, ma'am. Okay, very good evening to the dignitaries present on the online platform. I am Mr. Rajesh Mondal, and I am here to present on the topic of seepage analysis of conventional levee and fly ash levee subjected to flooding using different filter media. And my paper, generally the theme is geotechnical for sustainable cities. It is actually aligned with the vision of the Honorable Prime Minister Viksit Bharat 2047, a vision for India's sustainable development of environment sustainability. And this research has been conducted on IIEST Shibpur under the supervision of Professor Dipankana Bhattacharya. This is the flow of my today's presentation. And coming to the introduction, the topic with the relevant to India, rapid economic growth and industrializations increases the electricity demand. And from this figure, we can see, and from this data is collected from Central Electricity Authority report 2023. And 49.1% of this total electricity demand is generated from coal-based thermal power. And as we all know, coal-based thermal power plant produce lots of fly ash. And as the demand of electricity increases, fly ash production is also increases. And the problem of fly ash is it causes the environmental pollutions, health hazard, and it is required large area to dispose it. So we have to focus to utilize the fly ash. And as on 2020 to 2021, from report CEA, total 232.56 million ton fly ash is produced, and out of this, 14.91 million ton fly ash is utilized in various civil engineering fields. Out of which, as a geotechnical point of view, roads, flyover filling, mine filling, and reclamation of low-lying area, this 37% fly ash is concerned. And also, this 7%, unutilized fly ash, we have to use. So, if we, I have studied the where I can use the 7% unutilized fly ash. So here in this slide, I will discuss it. Uh, 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 where can we use the fly ash? Those 7% fly ash. So as per Rashtriya Bharat Ayog estimated, the total area that that is liable to flood is in our country is 40 million hectares. And for this flood, lots of social and economical damages are there, like monetary loss of life, houses damage, loss of cattle life. And for this, government target to provide a reasonable uh, protection measure for this 35 million hectare. For this, we have to construct the levee section. This is a levee section, and in this levee section, this side, left side is water side, and the right side is land side, which the levee section protect. And as per a report of Rashtriya Bharat Ayog, as on 2017, there is 37,073 kilometer embankment or levee section was constructed. So what is the problem to construct the levee section? Due to the unavailability of the natural granular material and some environmental regulations are there, and the excavation of natural materials consume vast energy. So it produces CO2. So carbon emission is there. So if we can use, the solution will be the fly ash can be used as embankment fill material. So the present guidelines of fly ash field road embankment is there, not levee there. So in present guideline, there will be a fly ash and there should be a earth cover of 1 to 3 meter. But the range is 1 to 3 meter wide range. And there is no design guideline. If we construct 1.5 meter earth cover, what will happen? If we provide 2 meter cover, what will happen? So this is the aim. The study of seepage analysis of conventional levee and fly ash field levee subjected to flooding and using different filter media there. So for this, I have to develop a numerical model and validate it with a conventional levee section model and undertake various parametric study with respect to earth cover. So numerical analysis is performed on the levee section as per the published database Saran and Viswanathan 2011 on the GeoStudio software. So the steps I am following that. First, I analyze in SIP-W with the help of steady-state seepage analysis for 180 days, then slope-W to determine the factor of safety with the help of Bishop method. SIP-W SIP-W replicate the hydraulic behavior, and the slope-W replicate the strength behavior of the slope. So here is the typical cross-section of the levee section. The left side, this side is 1 vertical, 2.5 horizontal. This side is reverse side. And the other side is, the slope is 1 vertical, 2 horizontal. This is the land side slope. And this detail is as per Saran and Viswanathan 2011. Here, a conventional levee section without drainage, any type of drainage is not used and then developed, and the results are published. And also with drain, the different types of drain are used, sand drains and geocomposite material drains. Every drains are modeled and developed here, and results are validated. But here I am presenting just sand drains thickness 500 mm and geocomposite material GCD2 used here and presented here. So to develop the model, I have to first define the points and region of the model. Then I have given the material properties to the model. There is levy section, foundation material, and the properties are same for levy and foundation, but the properties for drainage materials are different. Here, cohesion and friction angle is used for in the slope W, and unit weight and coefficient permeability is used in the SIP W. And the geocomposite material properties are tangential hydraulic conductivity and normal hydraulic conductivity are used here. So this is also used in SIP W. After that, I have used boundary condition, waterside slope. There is a 4-meter water pressure head, and landslide slopes, there is 0-meter water pressure head. After that, mesh convergence is done, and this is the mesh properties for different section. For levy foundation section, 0.4 element, triangular and quadrilateral use. And after that, fly ash material and geocomposite material, after the mesh convergence, these are the properties of element size and element type. After that, the results I have discussed here, hydraulic behavior and global safety factor, which is presented in here for my present study and Saran and Vishwanathan. In the left hand side, I have we can see that in this particular side, the left hand side, the results are from Saran and Vishwanathan, and from right hand side, the results obtained from present study. We can see that for pore water pressure contours with and without chimney drain, this is for without chimney drain and with chimney drain, the results are almost 1-to-1 match between both the literature and present study. Also for geocomposite drain, the results are 1-to-1 match. And the this is the factor of safety, global factor of safety, left hand side and right hand side almost similar, and the factor of safety for various drainage material are tabulated in this table. It is shown that the results are almost matched. So in my present study, after developing the model, I have replaced the middle portion with fly ash, and the earth cover thickness I am varying. The earth cover thickness 1000 mm, 100, 500 mm, 2000 mm, 2500 mm, and 3000 mm. I have done this thickness, and the hydraulic behavior and the global safety factor is checked in this model, and the procedure is same as discussed earlier. This is the properties of earth cover as mentioned in the levy and foundation material in this research paper Saran and Vishwanathan 2011, and the fly ash material property is taken from Mohanty and Patra 2015. Next, mesh convergence is done, and element size, mesh element size and mesh type is mentioned here. This is a result of fly ash field embankment, and left hand side represents the conventional levy section, and the pore water pressure parameters, the pore water pressure contours, which represents the hydraulic response, is same in the conventional levy section and fly ash field levy section. But when we use the fly ash field levy section with geocomposite drain, it will change, and this change is according to when we use conventional levy section with geocomposite chimney drain, this change is same. And the global factor of safety, when we determine the global factor of safety with respect to Bishop method.
Fast forward your presentation.
Okay. For conventional levy section without drain, it is coming 2.01. But when we use earth cover of 2.5 meter, it is achieving 1.9, not 2. But when we use earth cover 2.5 meter with chimney drain, it is coming 2.2 something. So we have this table depicts for thickness 1 meter earth cover, for thickness 1.5 meter earth cover, the factor of safety in the y-axis, and the x-axis represents the thickness of earth cover. So this represents that for thickness 3 meter, it is also when you use fly ash field embankment, it is not coming to. But when we use the fly ash field embankment with geocomposite material, it is coming at 1.5 meter greater than. So if we want to use fly ash field embankment we have to use the geocomposite drainage method. The conclusions are here. If we use the fly ash filled embankment, the pore water pressure is independent of any thickness of earth cover and similar to corresponding conventional levee with and without drainage chimney. And the factor of safety for geocomposite drain is essential. That mention I have also earlier, that geocomposite drain is essential to provide to achieve the desired factor of safety for fly ash filled embankment. So what is the novelty of the work? We can use the unutilized fly ash in the embankment. Lower unit of weight of fly ash reduce the load on underlying soil layers, so it settles less when it is weak soil and minimizes the extraction of natural soil. So what is the future scope? A small scale physical model can be developed on the proposed numerical model, and in this proposed numerical model, further can be extended to varying the high flood level. The water level we can vary, and we can check the related global factor of safety and hydraulic behavior. So this is my publication of this paper in IGC 2024. This is my references. Thank you.
Thank you very much for your nice presentation, Rajesh. Now I'm inviting questions and comments.
I just want to know from you, Rajesh, you have made a good study regarding from the strength aspect. Okay.
Yes.
But my question is basically, though there is a earth coverage over that particular fly ash layer, do you apprehend something about the water pollution leaching sort of problem?
I have studied in different type of papers, and as per Ministry of Environmental and Forest, actually fly ash or bottom ash or pond ash is non-hazardous matter. They're mentioning, but I also have to look into account the how much water is seepage and how much heavy metals is mixed into it. So this will be my future scope. How much water is?
Thank you. Rest of the things that we have got civil engineering experts, they can get it clarified here.
Yeah, that was my question as well, that you may have some pollution problem there with the heavy metals. Nice presentation, overall a good study. How about the the porosity? Does the porosity will change based on the other properties of the fly ash?
In which aspect, sir? Porosity, sir. Actually, if we dump fly ash, this will be compacted in the site. This will be compacted in OMC, and the compaction will be done as per IRC's heavy compaction test. So I don't think the porosity will change much.
Okay. All right. Thank you.
Anish, I have a question. It's not question, just again a curiosity. Do you think it is economically a feasible proposition to carry the fly ash from the location where it is generated to the location of embankment for its use?
Sir, where the material, natural soil is available, they can use. But where there is lots of places, recently I think a news from Kerala, there is no granular soils in between, I think 200 kilometer or 300 kilometer. So there's can be used, fly ash can be used, and there are lots of constructions in future. So fly ash can be used.
Thank you. Thank you.
Thank you. Do you have any more questions? Okay. Thanks, Rajesh.
Thank you, ma'am.
Our next presenter is Amal Mondal. And Amal Mondal is from the Civil Engineering Department. Rajesh, you stop presenting.
Ma'am, is it visible?
Your presentation is not visible. I can see myself on the screen.
Okay, ma'am.
It appears, but not on the screen.
Yeah, it appears in a small window at the bottom.
Yeah.
Now I can see the presentation. Yeah, and
Ma'am, is it visible?
Visible.
Yeah, it is there.
Thank you.
Okay. Thank you, ma'am. First of all, very good evening to respected dignitaries present in the online mode. Myself, Amal Mondal. Today, I am here to present my research work, studies on performance of geogrid reinforcement marginal soil subject to surcharge loading. This is come onto the theme of geosynthetics and reinforcement soil structure, which is perfectly aligned with Pradhan Mantri Atmanirbhar Bharat Yojana, which has the 5 major pillars, namely economy, infrastructure, system, variant, demography, and the demand. In my, I am totally focused on the infrastructure aspect, and total in this research totally is conducted in the IIST Shibpur campus under the guidance of Dr. Saptarshi Kundu sir and Dr. Dipankana Bhattacharya ma'am. This is the typical layout of my presentation, briefly introduction and research relevant, followed by highlighting the relevant research review, critical appraisal for the research topic, and I'm a little bit explaining the motivate behind the study and establishing my aim and objective. Then I'm going to the model study. And during my model study, the first step is to validate my research work and present my parametric study with discuss with result, and followed by conclude and highlighting the novelty, what and practical applicability, and last on the not studied I'm concluding the future scope and acknowledgement. Now I'm introducing the introduction part relevant to the India rapid expansion of a smart city and urban growth and population such as in need to a shortage of the construction ground. But most of the land has the we can call the poor subsoil condition because of different condition like liquefaction and all of the did this. And this type of soil can be utilized by geotechnical little bit aspect of ground improvement technique like geotechnical sorry ma'am improved by ground improvement technique. And in my case, I using geogrid reinforcement soil can be utilizing the one of the technique. From literature, I can say the sand is the using the construction material in eternity, but depreciation of the occurring sand and different regulation from the Ministry of Environmental is very much hard to obtaining the sand. This lead to study the identification of the alternative construction material. Locally available marginal soil can be is the cost-effective alternative soil. However, India has the 15% that is 0.49 kilometer in hilly terrain susceptible landslide zone area. Basically, Himalayan, Western Ghat, Nilgiri, Bindas are the almost among the aspect of the landslide. In this area has the marginal soil is the most. And now we will be talking about the marginal soil. A marginal soil is the type of soil which has the 10 to 35% of the fine content as per Christopher et al. And this type of soil has the low permeability and shear strength. You can see this graph from researcher Koener. He found after 171 mechanical stabilized analyzing the earth failure, he found 103, that is 61% of the structure failed due to the fine grained soil because of the excessive pore water develop, reducing shear strength and excessive deformation. And now this type of soil can be utilized using the geogrid reinforcement available by locally soil and environmental food, reducing the environmental footprint. You can see that this is the biaxial geogrid and uniaxial geogrid, and this is the typical layout of the typical layout of the foundation which I place the normally the geogrid for the structure like retaining wall slope stability. This is the few are the advantage of the geogrid. First, the increasing the shear strength, lowering the challenges of the slope failure, increasing the load deformation, loads, increasing the load bearing capacity, and structure like embankment and foundation, and cost effective. Because of the cost effective, the marginal soil decreasing the requirement of the high quality big and loading project. And more important is the easy to installment. GeoGrid has a lightweight, flexible, simple to install, making them the appropriate for the various application of harsh soil condition. Achieving my aim to develop design guideline for unreinforced and geogrid reinforced slope construction with marginal soil surcharge loading. To achieving my border aim, to need to be further subdivided. This is the few are the object I need to be achieved. First, needs to be achieved. They say conduct a numerical analysis, validate with the proper model, and investigation in slope inclination, shade back distance, marginal surcharge loading, etc. Before we using the numerical money need to be validated. In my case, I using Guthers et al. 2013 paper, and the material. All of these are from his paper. This is the figure. Generally, I use mesh and model for the for the validation purpose. And this is the 5-stage loading diagram. Black line shows the Guthers et al. And the dotted line presented by me. If a numerical model has the constitutional law, in my case, I using GeoStudy package version 9.1, and in my use the hyperbolic EV model. This is the mathematical representation of the EV hyperbolic model. Numerical model before you use need to be mesh conversion, because mesh conversion give you the optimum result and low cost. In my case, I using global mesh 0.5, 0.25, 0.125, 0.1, and local mesh reference. You can see the load deformation curve in that figure. A solid line from a Guthers et al. And present is at 0.25. I will get the optimum and closest value from this result, and that's why I choosing 0.25 and 0.1 is the my optimal mesh, and using this mesh for the rest of my analysis. This is the typically showing the figure of typical layout, typical figure of my model. This is the my model, and here H is the embankment height, and Z is the depth of the geogrid layer. B is the from this point is the crest to the surcharge loading, and this table shows the right hand side to my side is the constant parameter which are the fixed, and the left hand side of me this is the variable parameters, that is setback distance B from the crest to the surcharge loading, slope inclination angle. In my case 2:1, 3:1, and that's all. And surcharge loading is I using 25, 50, and 100 kPa. And for the numerical model analyzing, I using the paper from the Bhattacharyya and Vishwanath, and this is the material I have taken from this paper. And this is the layout of my numerical analysis. First, we generated geometry and material and modeling and geometry, boundary condition, and analysis the result and getting the deformation analysis. Now I'm talking about the numerical result. You can see this is the bar chart. Blue color column is the horizontal deformation is unreinforcement, and red color is the horizontal deformation in reinforce, and green color is the vertical deformation is unreinforcement, and yellow is the vertical deformation and reinforcement. This is the slope declination slope inclination 2:1, set base distance 1, 2, and 3. You can see increasing the load and deformation significantly reduced. For in this 2:1 vertical 2:1 slope inclination, I found that horizontal displacement decreased by 14.68% and vertical displacement decreased by 14.18%. Similar type of pattern I have observed from 3:1 inclination, and that is the horizontal deformation decreased by 13.34 and vertical deformation decreased by 16.59. And same type of observation I also observed from slope 4:1 inclination, that is horizontal deformation decreased by 15.79% and vertical deformation decreased by 15.57%. Now I am going to the concluding remark. Effect of the model, I also successfully validate and reinforcement of marginal soil appropriate or with GeoGrid can be utilizing the appropriate project cost. And deformation reduction, you can see this from 2:1. I also explained in the resultant discussion decreased by 14.68% and 14.18%. Similar kind of deformation is 3:1 and 4:1 as mentioned. And from the setback distance, I can observe that from the lowering the setback distance, they give the lower default displacement for optimum result I will get from the setback distance from B/4 ratio. Applicability and nobility. I'm trying to struggling the design guideline from unreinforced and reinforced GeoGrid reinforced slope or marginal soil under surcharge loading. And applicability, you can see the cost-effective approach
Fast forward.
aligned with sustainable development, support government initiative because of the GeoGrid and GeoGrid are locally produced, and it is the initiative, it is aligned with the PMT local for vocal initiative, also improve industrialization hazard mitigation. And feature scope, this is the few are the features who can we use in the further study. Likewise, couple hydromechanical analysis effect to find content variables such as condition, that is difference shape, depth, and size, and comprehensive guideline for the approach. And now in the whole art I the explaining is this is the only for the undrained case, and future issue can be using the drain case. You can see the rainwater which are pouring down, and using GeoGrid and geotextile is give the might be the good result because of the marginal soil has the low permeability and has the some drainage problem. Using GeoGrid and geotextile might be the good alternative source of this type of mitigated this type of problem. This is my publication, which is recently accepted by Springer in Nature, followed by the reference, which is the guideline pillar of my research and this topic. And last but not least, I thank you GAABESU and IIST Shibpur giving me this platform to explaining my this project. And heartily thank you Dr. Satota Kundu sir and Dipankana Bhattacharyya for their constant support and encouragement during this period. Thank you. If you have any question, please let me know.
Thanks, Amal. Very nice presentation. Now I'm inviting questions and comments.
Very nice presentation, Amal. Can you put up the slide with your publications list there?
Okay, sir. Yeah.
So you have already, so this is under preparation. Okay. No,
Yes, sir. Yes, sir.
yeah, right. I just saw it. Yeah. Okay, good.
Yes.
Your novelty, that slide that you had where you showed the novelty of your work, I can't remember the
Yes, sir.
slide number. Can you get that slide up?
Yes, sir. Yes, sir. It's a little bit
No,
difficult.
I think there was another slide. Anyway,
Okay, sir.
Can you reiterate, please, your novelty of your work? Because GeoGrid is not something that it has been done before, right? So
yes, sir.
Yes, please, can you go back and talk about your novelty? What is new in your work?
Actually, sir, marginal soil is a lot, very much a locally available soil. If you using GeoGrid and appropriate give the it mean what do you say? So try to design guideline.
Design guidelines. Exactly. What are the things that you are going to contribute? I just wanted to hear from you.
Actually, sir, is the slope angle and the setback distance, which will get the optimum result from this.
The setback distance is already there, no? But depending
Yes, sir.
on the right?
Yes, sir.
So, I mean, I just wanted to know exactly what you are. This is, I'm not, your work is good, no question there, but I just wanted to hear what are you contributing exactly?
Hello, sir.
You had a slide there, I'm pretty sure. I can't remember the number now. But anyway, that's okay. That's all right.
Yes, sir.
But anyway, when you are writing this, the papers and you're sending out to ASC and so on, this is one of the questions they're going to ask. What is your main contribution? And also just a suggestion that when you are sending it there, you should also compare with the guidelines that are also available in North America.
Yes, sir. Yes, sir.
Yeah.
Definitely, sir.
Yeah. Thank you.
Thank you, sir. Thank you, sir.
Thanks, Amal. Do you have any more questions?
Thank you, ma'am.
Okay. So thanks, Amal. I think we can move ahead with the next presenter. Our next presenter is Amal Pal. And Amal Pal is from the Civil Engineering Department.
Ma'am, Ayan Pal.
Very sorry, Ayan Pal.
Okay. Oh, yes, ma'am. Yes, ma'am. Yes. Ma'am, is it visible?
It's coming up. It's visible now, but not in presenters mode, though.
Yeah, ma'am, now it is visible in presentation mode. Now it is visible in
Yes, it is.
Okay. At first, good evening to everyone present here. I am Ayan Pal, currently a PG scholar in the Department of Civil Engineering, and I am presenting on my research topic of numerical studies on vertival root reinforced soil subjected to rainfall in the northeastern terrain of India. So my study is based on the slope stability and landslides aspects. It satisfies the Agenda 6 of Minister's 10-point agenda on disaster risk reduction. My research work is done under the supervision of Dr. Dipankara Bhattacharyya, Assistant Professor, Department of Civil Engineering. So this will be the flow of my today's presentation. So now coming into the perspective that landslides is one of the most critical hazards that happens throughout the world, and it kills thousands of lives and causing damages to infrastructurals as well as blocking roads and affecting the tourism and other sectors. So if we look into the world database, we can see that 5% of landslides, 5% of natural disasters happen due to landslides. And if we look into our Indian aspects, that India having in the top 4 countries which are prone to landslides, and our approximately 12% of landmass are hazardous. Our northeastern part and western Nilgiris are most prone to landslides, and that these types of landslides all are shallow slowing land failures. If we look into the world map, we can see that India having highest number of non-seismic hazards, landslide hazard, and thus all are mainly on shallow slowing slope failure. So we come to a conclusion that how landslides affects our socio-economical life by losing of life, migration, infrastructural damages, and impact to tourism and floods. So my primary objective is to explore an environment-friendly and cost-effective technique for slope stability and impacts on factor of safety of slope during rainfall for a typical northeast region. So now the question comes how root reinforced or vetiver could be helpful. So vetiver is helpful because it's reduced the surface erosion and erase the soil. It protects against raindrop and it's act as a mechanical action of root reinforcement. It's induced cohesion. As we all know, the soil have two types of parameters: cohesion and friction angles. And it contributes in strength. Due to root reinforcement, the cohesion part increases. And another essential thing is that soil is weak in tension, and root produce a tension component, tension property inside the soil due to root reinforcement. So now there is already vegetation available throughout the field and slopes. So now why vetiver? So we can see that vetiver has a wide range of acceptability. Means it can grow in acidic and alkalinity, and its roots are very much fast growing. In a year, it can grow up to 2 to 4 meters. And if we look into some famous project like Yadana gas pipeline, which is from Myanmar to Thailand, they have used vetiver as a slope stabilizer. And in West Bengal government, to use some of the river protection, they have used vetiver for slope protection. So this is a indigenous knowledge that vetiver is been used by other countries from very past, and we can see that vetiver is one of the perennial species that has grown in the Northeast India. This is a typical exhibits applicability in diverse soil types, and notability is that its rapid growth rate. Limited studies has been now the critical appraisal is that limited studies has been conducted in majority of the numerical analysis, and increase is been assumed constant with depth due to vetiver reinforcement. The application of vetiver is not widely used in India. The variation strength with time was not monitored properly. Few researchers has performed in situ box share investigation, but no guidelines was given for field implementation. And why to perform field experiment? Because due to in laboratory experiment, when we collect the samples, there are a lot of disturbance, so we cannot get the correct result. And the depth up to which strain properties are increased was not quantified. The combination of other plant with vetiver may be more effective. The season-based suit for plantation and growth of vetiver and the critical spacing between two samples was not discussed. So my aim is to propose an environment-friendly way, environment-friendly, cost-effective techniques, and numerically evaluate the parameters which increasing the strength and check its factor of safety. So now deformation. To reach to my aims, I have to model the rainfall infiltrations and the reason of failures via GeoStudio software using SIFW and SlopeW coupled analysis, and to evaluate the effect of decrease in strength with depth due to vetiver root reinforcement through numerical investigation. So this is the model how I have done. To validate the model, I have taken the paper of Raharjo et al. And I have validated the model. The steps is being followed is analyzing using SIFW, and after that I have done a transient CPN analysis to simulate the rainfall effects, and corresponding SlopeW analysis was carried out to using Bishop's method, and factor of safety was calculated after each 4.8 hour interval. and as in the numerical investigations, meshing is a critical aspect. I have modeled the top 5 meters of fine meshing, and after that, coarse meshing was given so that we can get easily the results. So this is the hydraulic properties which I adapted from the paper, published paper of Raharjo et al. And this is the boundary condition. So coming from the boundary condition, the red marked boundary condition is the no flow boundary condition, which helps a constant water flux boundary condition, which is 0, that dissipate no flow will occur. And at the two sides of the slope, there was a given was of water total head boundary condition, that's dissipate water head and water table, and the rainfall boundary condition was given as a water flux. And the potential seepage phase review was on, and this dissipates no ponding happens over the slope. And these are the parameters used for slope W analysis. And the result from the published Raharjo et al. And my present study was conservative and thereby validating my numerical model. So for taking into account that this type of account, I have taken from the published literature of Dhanai et al. The published data of a northeastern region of Assam, and the height of the slope was 10 meter, and I have done various parametric studies, that is variation of strength with depth. So this is the main thing in my research, that all the researchers have tested the top of the superficial layers, and in my study, I have taken that decreasing effect with depth due to root reinforcement. Due to root reinforcement, cohesion was increased. It's obvious process, but with depth, the cohesion decreases. So now I have taken different slope angles, 30 degree and 45 degree, and I have planted the tree numerically in different part of the slope. And different rainfall intensity was 9.8 meter per hour and 53.48 mm per hour. And these are the soil properties of Assam. And in the table 2, I have given the properties which I assumed as a decreasing effect of due to vertical reinforcement. So this is a 20 parameter studies I have been done, and here is the graph of them. From the graph 1, we can see from the TN1 result, we can see the factor of safety for unreinforced soil, and TN2 and TN3 we can saw the result when the cohesion was kept constant, and we can get higher factor of safety. But in actual field implication, the factor of safety comes from test number 4 and 5, and this should be adapted for all practical approaches. And for that, for other result, I have done the same analysis. So this is a quantified summary of the tables, and I will be discussing them now in a quantified manner. This result indicates that rainfall intensity, that rainfall created an infiltration in the slope, and the factor of safety decreases. And due to after post rainfall, the matrix suction recovery was happened due to vertebral root reinforcement. Further, it can be inferred that effect of vertebral root is more pronounced for a configuration 45 degree slope, and the fact that steeper slope benefits more, that root susceptible to stop shallow failures, and root counter the same by pushing the failure surface deeper into the slope. Additionally, the placement of vertebra can be observed more beneficial when the top surface and face of the slope rather than concentrated slowly on the face of the slope. So the nobility of the work is that vertebral roots in arresting shallow swing failures, and the nobility of the study is that it has accounted the variation in cohesion with depth, and showing the difference in the corresponding result by assuming the constant with depth. It can be inferred that variation of apparent cohesion with depth present more realistic result that should be adapted for all practical purposes. And my practical applicability is it can be used towards sustainability, and vertebra can be helpful to mitigate face failure in the northeastern part of India, and it can also be used for river protection widely. So now to evaluate, so this is my future scope to evaluate the in situ parameters. I will develop this. I have modeled, and this is under fabrications. I will develop this type of apparatus to test in situ apparatus, this will look like this. I have made a visual, I have also made a video simulation of this through my research time. And this is how the apparatus will work, and I can found the increase in strength by this. To procure vetiver, I have went to the Jalpaiguri and I have procured the vetiver sample and I have planted it inside the campus.
And forward your presentation. Thank you.
Ma'am, one few minutes. I have planted the plants inside the campus, and these are undergrowth. And I have published my numerical part in the IGC conference, and this is accepted as a book chapter, and GAABESU has helped me to present the paper in the IGC conference, and this is my reference, and I also thankful to my supervisor and other faculty of the Department of Civil Engineering department and the computational facility that I availed from the department, and the GAABESU for giving me opportunity to present the paper in the IGC conference. Thank you for listening to me.
Thank you very much, Ayan, for your nice presentation. Now I'm inviting questions. I have one question, Ayan. So I think your model depends on some parameters that you got from a paper that uses values from a study done specifically for Assam, right?
Yes, ma'am.
For the state of Assam, right? So how generalizable are your conclusions for other states of the Northeast?
Ma'am, actually, looking into the aspect that means I have to, if you have to use the other state, we have to plan them because it depends on their quality of soils and their parameters. So it's obvious a point of that field applications. That's why I am planting the tree inside the campus, and I will monitor its growth. Means we are already monitoring them and we will publish them. Yes, there in field application there are challenges. Obvious challenges are there, but we have to implement them in a few of the part. And if in future I have got some of the works, I have talked in this conference. I have get opportunity to meet some of the esteemed. They have worked on whatever like MP Birla Cements. MP Birla, they have already started working on fabrications of this whatever and geotextiles. They have already using these products. They have told me to if we can come to their sites and test these in situ parameters after fabrication of in situ apparatus, we can do so and find how the effects are changing.
Okay, thank you for your answer.
How did you consider the vertebral mass in your model, that is during meshing, as a monolithic mass or as a bunch of fibrous elements?
Actually, sir, in GeoStudio, I have just increased the means due to vertebral reinforcement, the tension effect I does not consider. So I have just increased their strength only at that part where the vertebra is planted. I increased the strength only, that C and 5 values. Only that I have added and I have run the model. Means actually, sir, in GeoStudio we cannot model the root fiber. That's why we have to increase the cohesion, and this approach has been adopted by other.
How did you correlate it? How did you correlated the amount you have increased with the property of vertebral mass?
Sir, in the table, there was a study happened in D'Souza et al. He has done a test on. I am much I remember that he has done a test in Assam region, and he has quantified his table data, and I have used for numerical analysis. I have used his data, and for experiment, and I have not done experimental yet because I have to done it after 1 year, and I have completed not yet 1 year of plantation.
Thank you, man. Thank you.
Yes.
Do we have any more questions? Okay. Thanks very much, Ayan, for your nice presentation. Yes. So now we have our next presenter, and next presenter is Kiran Pal. from the Civil Engineering Department.
Yes, ma'am. Am I audible, ma'am?
You are.
Good evening, everyone, and my respected sir and ma'am. I am Kiran Pal from final year.
Kiran, we need to see your slides.
Is it visible, ma'am?
They're visible, but not in the presenter mode yet.
Now, ma'am?
They're good now. Thank you.
Again, good evening, everyone, and my respected sir and ma'am. I am Kiran Pal from final year undergraduate student in Department of Civil Engineering at IIEST Shibpur. And I have done my research paper under guidance of Professor Soumyadeep Bhattacharyya, sir, Department of Civil Engineering at IIST Shibpur. My research topic is an improvement sustainability measurement for concrete building. Now come to abstract. Mainly environment and structure sustainability of building stands as a important issue in recent years to cope with the challenge to keep green earth simultaneously assuring the durability aspect of structure. So this study proposed an improvement evaluation method that incorporates material quantity weightage for our for 4 different structural systems in a 2-story building. The result highlighted in significant consider the material quantities in sustainability assessment for accurate environment impact evaluation. Now, our problem is the conventional method to measure sustainability often disregard material quantities and focus only quantitative factors. And objective propose a modified sustainability evaluation procedure incorporating the relative material quantities. And I have reviewed some paper like EAC, sustainability assessment of concrete structure within the Spanish Structural Concrete Code, AAC 2023. And this paper I review and from there I got some model that say that model I developed the more accurate value. Now come to the introduction. This project actually originally developed from a Spanish structural code. So here I describe mathematical model that we have developed from previous study. And we have improved the model to include the volumetric ratio, different materials as used as construction, and environmental sustainability of structure. Construction is a major concern this day as major part of the earth crust is now populated with concrete or steel structure, and the green planned area has been reduced discretely. And now this is a environmental ISMA, the Environmental Sustainability Index. This is popularly measured by EH08. This is our Spanish code, and which is developed for a RC structural only. Now come to this is a tree. This is a tree model. The criteria of a this is the tree. Am I audible, ma'am?
Yes, you are. Yes, you are audible. Hello, Kiran.
Yes, ma'am. Yes, ma'am. This is a different criteria of characteristics of concrete supply, or characteristics of materials and reinforcement reduction, steel characteristics like this. And this is a tree type of model that is depends upon the different environmental sustainable for different level of criteria. That is sub-required level and requirement level and assessment level. This is the Environmental Sustainability Index ISMA structure is defined as the result of actually there is a 11 different criteria. These are the skill 11 different criteria that should be considered for our research case. Now our conventional approach. This is a VI means the value of factor determined for each criteria of according with the following expression according to the representative parameter each case, and there K, AMI and NIAI is a parameter for value depends on each indicator. And now this is we can calculate from here ISMA value, and after that another model is a ISE. This is a structural contribution sustainability index, which is we can modify it from here. We modified the this structure, the MICS model. This is a modified ICS value. This is a ICS equal to A plus B into ISMA, which is the factor A and B is respectively social contributor factor and contribution factor due to the extension of work life, and obtained from our table A.13.5 in as per the Spanish code. And from here ISM and ICS better is the better environmental sustainability of a structure. Now, conventional approach, ISMA considered the environmental impact of ingredient waste recycling, particularly the waste product, and decrease the CO2 emission in steel production, level of the execution control and type of mixing concrete, we use of ceiling reinforcement, whether welding is used or not. However, mention the conventional approach neither take into the consideration other than RC building, not the relative volume difference materials. Also, nowadays several alternative materials such as a fly ash brick and autoclave marinated concrete block and geopolymer concrete are getting a popular to produce lightweight and eco-friendly and cost effectively. This is thus alternative estimation of ISMA is proposed this study. This is a our proposed the proposed approach. Let us one example. Here we have taken some materials value, which is the ES environmental sustainability of RC building 0.12, and similarly environmental sustainability of AC block is 0.16, and thus it can be inferred that the general the ACJ value we get from 0.16 divided by the RC compared with RC building. So we get the 1.33 times more environmental sustainable materials than the RC. Similarly for clay, and I have studied some paper like they have some given some yes value. This value 0.212 and this 12. These are value we got. We have studied and get the value. Now this is our first step by proposed approach. In new materials, ES factor, environmental sustainability factor defined, and here we compare the our proposed in this SMI in the new material ES factor, which is measure of a material under considered and RC and RC. So there we compare the value and we got the value better result from this previous model. Now come to the proposed approach. Now second step is the proposed approach is a calculated volumetric ratio of the materials used for a particularly construction project. This is a parameter my total number of materials used of a building and construction, including the interior decoration. And this parameter encompasses the quantities and type of various material used in a construction project. and including the finishing and decoration. Now, the purpose final step of the computed modified IESS value, which is we have in our study we modified the ICS to MICS modified ICS value, which is more accurate and in our research. This is this MICS is it may be notified from above the equation, and that RC materials only MICS and ICES become identical. In this way, relative weightage of a quantity of various materials and their associated ES is including the definition of proposed MICS. Now, this is a, for example, if clay brick and RC are two materials using a 50-50%, then the proposed multiplier become a 1.14 value. So for a RC and also CB. Now the MICS is a 54% of more than RC because using the CB higher than the MICS, better than is ES. This parameter MICS basically indicates the advantage or disadvantage is using the choose materials with their quantities for a constructional project. According to the planning and design may be monitored to import more MICS of construction projects. This parameter is a more general one, and as it is encompass all the types of materials with their relative quantities. Now, this is our numerical study. This is a 250 cross 250 design, and thickness is 150 mm, and grade of concrete 120, and Fe 500 grade of steel, and the inner outer CB. Now come to the result. The result compared to side by side four types of system, namely RC frame CB field and RC frame structure with fly ash in field, and RC frame structure and AC block, and also
fast forward your presentation. Thank you.
Yes, okay, ma'am. Okay, ma'am. And also a load bearing CB structure. It can be observed from the figure for all four types of building. The ICS it is the identical value 0.15. This cannot be actual. This cannot be actual value, and whatever we have found the this is existing model 0.15, and this value for every materials which is not correct. But our own model that is that the modified MICS of is given different value and different materials, we get a good result. We are compared the different materials for their environmental sustainability. Our observation, the four types of four system yield four dimensioning and different value of MICS by proposed approach. The maximum value of MICS is with clay brick system, where the minimum MICS value is associated with AC system, even less than RC system. The maximum environmental sustainability by clay brick is quite obvious, as clay brick is established to eco-friendly, and this is a being a reason that a AC system has a least environmental sustainability even compared to RC system. But since system is a lightweight and economic as well, ones can explore use waste recycling and much as possible to production of AC. Now conclusion come to a new measurement approach construction project is proposed. A modified version ICS, which is we are modified MICS, which take into account relative ES measure of various materials used in a construction project along with their relative volumetric ratio. The effectiveness proposed environmental sustainability approach with the well-established example two-story building with our 4 types of system. Now, the results show that the conventional environmental sustainability approach predict the identical value of environmental sustainability for all the 4 types of building system. This is obviously questionable since there are 4 different types of building system with different materials and with different quantities of materials used. So will affect the environmental differently. So on other hand, the proposed approach captured this issue satisfactorily, and the clay brick yield the maximum environmental sustainability, whereas the AC infill produce least environmental sustainability measure. This is my reference, and thank you. And this paper published international conference in Jadavpur, Indian organized in Indian Concrete Institute. Thank you, sir. Thank you, ma'am.
Thanks, Kiran, for your nice presentation. Now I'm inviting questions for Kiran.
Ayan, can you hear me? Ayan, can you hear me?
Sir, actually, my name is Kiran Pal.
Oh, Kiran, sorry, I'm confusing. Yeah, because continuously, thank you. Sorry, I'm extremely sorry. So, Kiran, my query is, you are talking about the sustainability, and out of that, environmental sustainability is your assessment criteria. Are you aware of ISO 14000 series?
Yes, sir. Actually, sir, environmental sustainability development refer to meeting human needs while preserving the.
Question is very specific. Are you aware of ISO 14000 series? Yes or no?
No, sir.
Fine. Whenever you are talking about environmental impact, then what should be the comprehensive method of assessment? Any idea? Because the sustainability needs it.
Yes, sir. There are 12 parameters for different sustainability index. Like
and when you are talking, and 12 parameters have been defined. So when you are coming to the social sustainability issue, you talked about a little bit on that also. How many parameters are there?
12 parameters, sir.
Social?
Social, sorry, sir, can't remember.
Okay,
but I studied in our literature review.
So whenever you are assessing the environmental sustainability, do you think the other sustainability will also be important, economic?
Yes, sir.
So have you considered in your study at all?
No, sir.
Okay, fine. Now my questions are over. Ashirbani.
We have more questions from the audience for Kiran.
Well, while you were discussing the sustainability index at different level, alpha, beta, and gamma parameter takes different value.
Yes,
right?
sir.
So how do they determine this value? Is it theoretically obtained or experimentally determined?
Yes, sir. This value come from our as per our Spanish IS code. There have some criteria for different sustainability from different like characteristics of concrete supplier and characteristics of reinforcement supplier and steel characteristics like this. There are from there we got the value from different
I understand there are certain values, but are these values specific and general for say supplier?
Yes, yes, sir. This is specific
value. Vary from case to case.
Case to case varies, sir. So depends upon various cases.
So these are set of values you have taken or you have shown like that.
Yes, sir.
These are not universal values.
Yes, sir.
Thank you. Thank you, Kiran.
Thanks, Parthoda. Do you have any more questions from the audience? If not, so Kiran was the last presenter of today's session. I'd like to hand it over to Shopanda.
Thank you, sir. Thank you, ma'am.
Students should leave, no?